Hello students, I hope you all are fine. Today we are going to discuss types of function. In function, we studied what is domain, what is codomain, what is range, what is image, what is free image. In today's topic, we are going to discuss what are the different types of function. So very first type of function is one-one function. What is one-one function? A function is called one-one function when every element of the domain have distinct image. Means image of the every element of the domain should be different. How? For example, we have a function in which domain of the function is A. Its elements are 1, 2, 3, 4. We have its codomain B, whose elements are A, B, C, D. Now, by putting 1 in the function, we are getting A. By putting 2 in the function, we are getting B. By putting 3 in the function, we are getting C. By putting 4 in the function, we are getting D. Now you can see, for every element of the domain, we are getting distinct image. See, for every element we are getting different images. All are having their different images. This type of function is called one. This type of function is called one function. Here we have a function f defined from x to y. X is domain, y is its codomain. Function is given as fx is equal to 2x, where domain is 1, 2, 3, its codomain is 2, 4, 6, and we have to check whether the given function f is 1 or not. How we can check whether a given function is 1 or not? The definition says that every element of the domain will have different images. How? We will check whether every element of the domain have different image on the codomain or not. How to check? We have function fx is equal to 2x. When x is equal to 1, so f of 1 is equal to 2 into 1 is equal to 2. For second element 2, x is equal to 2, f of 2 is equal to 2 into 2 is equal to 4. For x is equal to 3, f of 3 is equal to 3 into 2 is equal to 6. So, we got image for every element of the domain. Now we can check it. We have domain x, we have codomain y, we have domain x. Elements of the domain are 1, 2, 3. We have codomain y. Elements of the codomain are 2, 4, 6. When we are putting 1 in the function, we are getting 2. So image of 1 is 2. When we are putting 2 in the function, we are getting 4. So image of 2 is 4. When we are putting 3 in the function, we are getting 6. So image of the function 3, f of 3 is 6. So what we got here? We got every element of the domain have different images, distinct images. So here we can say that the given function f is one function because every element of the domain have different images. So we have seen how to check a given function is 1 or not. But one thing is there, the domain of the given function is a finite set. Means their elements are limited. Domain of the given function is a finite set. So in finite set we are able to put every element and check. But in a situation where the domain of the function is a infinite set, like in this example, here we have a function f, n to n. Domain of the function is a natural number, and we have fx equal to this, where x belongs to a natural number. Again we have to check whether f given function is 1 1 or not. How to do this? We cannot put and check each and every element of the domain, which is a infinite set. So there is a working rule to check whether a given function is a 1 1 function or not. This working rule says that we have to consider two distinct elements of the domain, such as x1. We have to consider that x1 belongs to natural number and x2 also belongs to its domain, which is a natural number. Then we have to equate f of x1 and f of x2. Then we have to equate f of x1 is equal to f of x2. F of x1 means, put the value of x1 here, so we will get 2x1 plus 3 is equal to f of x2 is equal to 2x2 plus 3. 3 and 3 got cancelled, so we got 2x1 is equal to 2x2. 2 and 2 got cancelled, so we got x1 is equal to x2. Now we taken f of x1 is equal to f of x2. That means we have taken the image of a function to be same. Now we proved if image of the function are same, then both the elements x1 and x2 are also same. That means for same element we are going to get same image. Hence we can say that f is a 1 1 function. Is a 1 1 function. This is the working rule for checking whether the given function is 1 1 or not. Now the second type of function we have is many one function. Many one function is just the opposite of the 1 1 function. Like in 1 1 function, every element of the domain have different images. In opposite, a function is called many one function if two or more than two elements of the domain have same image. How? For example, we have a function in which its domain is A, elements of the domain are 1, 2, 3, 4, and we have codomain B, elements of the codomain are A, B, C, D. Now we have a function, when we put 1 in the function, we will get A. When we are putting 2 in the function, we are getting B. When we are putting 3 in the function, we are getting C. When we are getting 4 in the function, again we are getting C. So we got for two element, we got same image, many one image. That's why this type of function is called many one function. There can be more than two elements also. For example, we have element 5. When we are putting 5 in the function, again we are getting image. Two or more than two elements of the domain of the function are having same image. This type of function is called many one function. And how to check whether a given function is many one or not? The working rule to check whether a given function is many one or not is same as the 1 1 function. We are in the same way we will take two elements x1 and x2. We will equate f of x1 and f of x2. Then if you prove x1 is not equal to x2, then here we proved x1 is equal to x2. Then this is a 1 1 function. By using same working rule, when we will prove x1 is not equal to x2, then the given function is many one function. Just opposite of the 1 1 function. Now the third type of function we have is onto function. What is onto function? A function is called onto function when every element of the codomain is image for some element of the domain. How? Suppose we have a function in which domain of the function is A, where its elements are 1, 2, 3, 4. We have its codomain as B. Elements of the codomain are A, B, C, D. Now we have a function f. By putting 1 in the function, we will get A. By putting 2 in the function, we will get B. By putting 3 in the function, we will C. By putting 4 in the function, we will get D. Now, what we can see here? We are saying that every element of the codomain is a image. That means no any element is left which is not a image. That means every element of the codomain is an image for some value of domain. This type of function is called onto function. So we can conclude in a single word that when in an onto function, set of range is equal to set of codomain. When set of codomain is equal to set of range, means all the elements of codomain are the range also, means they are image also. This type of function is called onto function. Now the question is how to check whether a given function is onto or not. To check, again we have a working rule how to check a given function is onto or not. Here we will understand about the working rule to check whether the given function is onto or not. Suppose we have a function fx is equal to x square, which is defined from real number to positive real number. Check whether f is onto or not. The working rule to check onto function says that we have to take one element from the codomain, that is R plus. Suppose y is an element of the codomain which belongs to R plus. Then if y belongs to R plus and in onto function every element of the codomain is a range, is an image, that means we can say that f of x is equal to y. For some value of x, when you put in the function, you will get the y because y belongs to R plus. Then f of x here is x square. So x square is equal to y. Now here we can see that y is written in terms of x. We have to reverse it. The working rule says that we have to write the value of x in terms of y. How? We will transpose this square this side. So we will get x is equal to plus minus under root y. We have written x in terms of y. Now we have to check whether this value exists or not. If this value exists in the domain, then this x also exists. If this value exists, then x also exists. If x exists in every value of the domain, then that means the given function is a onto function. If every value of the codomain is defined, then that value corresponding to it, the domain, the value of domain is also defined. That means for every value of the codomain, there is some value for in the domain. That function is called onto function. So we have to prove that this value is defined. How to check this? Y is defined. Y belongs to the set of real numbers. So we have y belongs to set of positive real numbers. If y is positive real numbers, then square root of positive real number is also real number. Square root of a positive real number is also a real number. And when we apply the plus minus, so plus minus of real number also belongs to, and when we apply plus or minus, then it also belongs to real number, because a real number contains all negative and positive numbers. Hence we proved plus minus under root y belongs to a real number. Hence we can say that x is defined because this value is defined. If x is defined for every value of y, that means this function is a onto function. Hence we can write f is a onto function. This is the working rule to check whether a function is onto or not. Now the fourth type of function we have is into function. As we know, for onto function, every element of codomain is the image. Now, in this into function, this is the opposite of. In this into function, at least one element should be there in codomain which is not the image. This is the criteria here. Like we have a set A, element of set A are 1, 2, 3, 4. We have a second set, that is set B. Element of set B are A, B, C, D, E, F. These are the elements. Now, this is our function f. When we put value of 1 in the function, suppose it gives A, 2 will give B, 3 will give C, 4 will give D. Now we can see that here 2 elements are left. That means these 2 elements are not the image for any value of domain. This type of function is called into function. If one image left, if one element of the codomain left, suppose only E will left, then this will also satisfy the criteria of into function. And this into function can be also checked by the same rule we learned for onto function. Like we proved for onto function, every element of x is defined for some value of y from codomain. But in into function, this criteria for every value of codomain, we do not get the x because they are not the image for any value of x. Then how we can get the value of x? Then for that value of y, how we can define the value of x? That's why from here, by using same rule, we can check whether the given function is into or not. If for single value of y, that means from codomain, x does not exist, that means that function is a into function. Now the fifth type of function we have is 1, 1 onto function. As we can see from the name, this function is a combination of above two types, that is 1, 1 type and onto type. The function, so we can define this function as the function which is 1, 1 as well as onto is called 1, 1 onto function. That means this function will satisfy the criteria of 1, 1 function. It will also satisfy the criteria of onto function. This type of function is called 1, 1 onto function. We also call this function bijective function. For a set A whose elements are 1, 2, 3, 4, we have a set B whose elements are A, B, C, D. Now, there is a function f which associate element of set A to element of set B. Now, when we put 1 in the function, we are getting, suppose we are getting A. When we are putting 2 in the function, suppose we are getting B. For 3 we are getting C, and for 4 we are getting D. Now you can see here that every element of domain have different image there. Different image how? For 1 we have image A, for 2 B, for 3 C, for 4 D. That means all the elements have different images. That means it is a 1 function. 1 function. Now from the codomain, not a single element left which is not a image. Every element A, B, C, D are the image for some element of domain. That means this function is also a onto function. So together we can say that this function f is called 1 onto function because it is satisfying criteria for both the function. Here we will understand this 1 onto function with example. Here we have a question which says that check whether function f defined on R to R, real number is domain and real number is codomain also. Defined by f of x, rule is given 3x cube plus 5 for x belongs to real number is bijective function. You have to check the given function is bijective or not. Bijective means 1 onto function. How to check the given function is 1 onto function? There is nothing new. First, to check whether the given function is 1 onto, first we will check it for 1 function. First we will check for 1 function. We know what the working rule for 1 function says. It says that we have to assume two elements x1 belongs to R and x2 belongs to R because R is a domain. Now we have to find f of x1 is equal to 3x1 cube plus 5. F of x2 is equal to 3. We got f of x1, we got f of x2. Now the working rule says that we have to equate and get the value of x1 and x2 and get the relation between x1 and x2. So let us equate them. F of x1 is equal to f of x2. F of x1 is equal to 3x cube plus 5 is equal to 3x cube So this f of x1 is equal to 3x1 cube plus 5. F of x2 is equal to 3x2 cube plus 5. 5 and 5 got cancelled. We left with 3x1 cube is equal to 3x2 cube. Now 3 and 3 got cancelled. We got x1 cube is equal to x2 cube. Now we can conclude if cube of two numbers are equal, then we can say that x1 is equal to x2. We taken f of x1 is equal to f of x2 and we prove x1 is equal to x2. That means the given function is 1 function. So we have to write so f is 1 function. Now we have to check it for onto function. For onto. Now we know the working rule for onto says that we have to consider one element y from the codomain and we have to write x in terms of y. So let us consider y is the element of codomain. Codomain there is R means set of real number. So y belongs to R. If y belongs to codomain and every element of codomain is an image, that means y is equal to f of x. f of x is equal to, and this f of x is equal to 3x cube plus 5. Now we have to write x in terms of y. How? When we transpose 5 this side, it will become y minus 5 is equal to 3x cube. Then we will transpose 3 this side, it will become y minus 5 upon 3 is equal to x cube. Again, cube will be transposed and it will become cube root. That is, so x is equal to y minus 5 divided by 3 to the power 1 by 3. So we have, what we did here, we written x in terms of y. Now we have to check whether this x is defined or not for every value of y. How to check it? So we will start from the beginning. Like if y belongs to real number, y we taken the y belongs to real number. If y belongs to real number, so y minus 5 will also belongs to real number. If y minus 5 belongs to real number, so we can write that y minus 5 upon 3 will also belongs to real number. Y minus 5 is also real number. So y minus 5 divided by 3 is also a real number. If this is a real number, so we can say that y minus 5 divided by 3 whole to the power 1 by 3 is also a real number. Cube root of real number is also a real number. So we proved this value is a real number. For every value of y, x is defined. There is a x. There is some x present. That means this function is onto function. So here we prove the given function 1 1 and onto. They are both 1 1 and onto. Hence we can say that the given function is bijective function.